So yesterday I had given you this problem, right? Given x of n is equal to minus of n plus 8 between n is equal to minus 8 to minus 3. It is equal to 6 for n is equal to minus 3. It's equal to minus 6 between n is equal to minus 3 and 0. It is equal to n between n minus 1 to 7, 0 otherwise. So we have understood, right, how to plot this. So here in this problem, what are they telling you? So from this we can see that our range of x of n will extend from minus 7 to plus 6. Okay. So our signal extends from minus 7 to plus 6, that is x of n. So we shall see what are the amplitudes at each instant of time. Okay. So they are given you, amplitude is minus of n plus 8 between minus 8 to minus 3. Okay. So n is less than minus 8, that is minus 7, and it's greater than minus 3, that is minus 2. Okay. So n is greater than minus 8 means it's minus 7, and it is less than minus 3 means minus 4. Sorry, it's minus 4, not minus 2. So between minus 7 to minus 4, the amplitude is minus of n plus 8. You have to substitute the values of n at that particular instant, and we have to plot. So we'll start plotting. So first we shall plot this minus of n plus 8 between minus 8 and minus 3. What did you understand from this? N is greater than minus 8, that means it is minus 7. It is less than minus 3 means it is minus 4. Okay. So the value of n between the range minus 7 to minus 4 is minus of n plus 8. So how do we do that? So we have at minus 7 we have to plot. Minus of what is n at minus 7? It is minus 7 plus 8. What do you get? You get minus of 1. So it is minus 1. Correct? At minus 7, the amplitude is minus 1. Again, minus of, we have next integer is 6, minus 6, right? So minus of minus 6 plus 8, you get, which is equal to minus 2. Okay, so at minus 6, you have amplitude range minus 2. Okay, and at minus 5, you have minus of minus 5 plus 8. So we get minus 5 plus 8, you see, what is that? It is 3. Minus of 3 is minus 3, which is equal to minus 3 at minus 5. The amplitude is minus 3. Next, we have minus of minus 4 plus 8, which is equal to minus of plus 4, which is equal to minus 4. At minus 4, the amplitude is also minus 4. Okay. It is equal to minus 4. And they have given it is 6 for n is equal to 3. Correct? It is 6 for n is equal to 3. So at n is equal to, sorry, n is equal to minus 3. So at n is equal to minus 3, it is 6. Okay. Then it is minus 6 for n between minus 3 and 0. So what they are telling you? Between n minus 2, n is greater than minus 3 and less than 0. That is, the range of values between these two are minus 2 and minus 1. So for minus 2 and minus 1, the amplitude is minus 6. Okay. For minus 2 and minus 1, the amplitude is minus 6. Okay. Minus 6 and minus 6 for these two. Then again it is n for n greater than minus 1, less than 7. That means between the range minus 1 to minus 7, that means n greater than minus 1 is 0, n less than 7 is 6. So from 0 to 6 it is n. So that means at 0 it is 0 into n. That means if n is equal to 0, if you substitute the value of n as 0, it will be 0 only. At n is equal to 1, it is n, that is 1. Okay. At n is equal to 2, it is 2. At n is equal to 3, it is 3. Amplitude. At n is equal to 4, it is 4. At n is equal to 4, it is 4. At n is equal to 5, it is 5. And at n is equal to 6, the amplitude is 6. This is our given waveform x of n. Did you all follow? Did you all do the same?
Yes, ma'am.
Yes or no?
Yes, ma'am. Yes, ma'am.
So you are expected to first plot x of n. First you have to graphically check what is x of n. Given x of n, they are given for each value of n, they are given different amplitudes. Okay. So this is your x of n. Now you have to plot y of n. Okay. What is that y of n? It is nothing but the question is y of n is equal to 3 times x of n by 2 plus 1. So what all operations are involved here?
Shifting and scaling, ma'am.
Shifting, scaling, and amplitude scaling.
Shifting.
Amplitude scaling. Okay. If you have amplitude -1 plus 1, if you have minus here, if you get plus, that is shifting. Okay. Else it is scaling only. Amplitude scaling, you call this. So shifting we will do first. What is that? We'll do x of n plus 1. Later we'll do x of n by 2 plus 1. Then we'll do multiply amplitude with 3. Okay. 3 times x of n by 2 plus 1. Shall we start to do this problem? Everyone ready? So first we have to do shifting x of n plus 1. So what happens to this x of n?
It will come early from -8 to it will go to +5, ma'am.
So x of n plus 1 means k is positive. X of n plus 1. K is positive. If k is positive, it is left shifting. Correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
So the signal is occurring 1 second earlier. Correct? So how will the waveform look? I want you people to plot. Okay, don't just observe. You also plot along with me. -1, -2, -3, -4. I doubt the space won't be sufficient. I'll rub this side. So shall I rub this part? This one? You people know, right? I'll rub this and I will plot here. Yeah, so I'll plot it here. Okay, x of n plus 1. Okay, so first we are doing shifting x of n plus 1. Then we'll do scaling. Okay, x of n by 2 plus 1. Then we'll do 3 times x of n by 2 plus 1. We'll do amplitude scaling at the end. So n plus 1 means the signal which is at 0 will go to +1 or -1?
-1.
Yes, it will go to -1. So whatever is at -7 will go to -8, correct? One time instant where it is occurring earlier. The signal, if k is positive, you have x of n plus 1, k is positive, the signal is, we are doing left shifting and the signal is occurring 1 second earlier. Okay. So whatever is at -7 will go to -8, whatever is at -6 will go to -7, so on. Okay. So at 8 you have -1, at 7 you have -2, at 6 you have -3, at 5 you have -4, and at -4 you have 6. And at -3 you have -6, correct? You have -6 here, and here also you have -6, and at -1 you have 0, and at 0 you have what? The amplitude 1, and at 1 you have amplitude 2, and at 2 you have amplitude 3, at 3 you have amplitude 4, at 4 you have amplitude 5, and at 5 you have amplitude 6. Got it, everyone?
Yes, ma'am.
We have shifted left by 1 instant or 1 second the whole signal. This is x of n and this is x of n plus 1. Understood, everyone?
Yes, ma'am.
Next, what should we do after this?
Scaling.
We have to scale this signal. Okay, it is n by 2 plus 1. Okay, x of n by 2 plus 1. So what happens to your signal? It will compress or it will expand?
Expand, ma'am.
So you're scaling by a factor n by 2 plus 1. So you're scaling by a factor 0.5. So it is x of 0.5 n plus 1. So what does this mean? What happens now? The signal which is at 0 will be at 0 only. What the signal which is at 1 will go to 2. The signal at 2 will go to 4. The signal at 3 will go to 6. The signal at 4 will go to 8. Signal at 5 will go to 10. Got it? The signal at 0 will be 0 only. We are scaling by 0.5, correct? So the signal at 1 will go to 2. Okay, so it is 2. Amplitude is 2, near 2. At n is equal to 4. Yeah, 10 is equal to 2, it is 2. At n is equal to 4, the amplitude is 3. Okay, at n is equal to 6, the amplitude is 4. At n is equal to 8, the amplitude is 5. At n is equal to 10, the amplitude is 6. Understood, everyone? You are following? So
Yes,
at minus 1, what is the signal? Sorry, at what is at minus 1? We'll go to minus 2. So at minus 1 we had 0. So at minus 2 also it will be 0. At minus 4, it will be minus 6. Correct? Minus 6 at minus 4, and minus 6 also at n is equal to minus 6 also it will be minus 6 only. Okay, so at minus 8 it will be at 6. So at n is equal to minus 8, amplitude will be plus 6, and at I'll rub this. We don't need this much here. So at n is equal to minus 10, it will be minus 4. At 12, it will be at n is equal to minus 12. How much is the amplitude? It will be minus 3. At n is equal to minus 14, it will be minus 2. At n is equal to minus 16, it will be, how much is that? At n is equal to 16, minus 16, it is minus 1. Okay? Got it, everyone?
Yes, ma'am.
Understood?
Yes, ma'am.
Our signal has expanded now because we are scaling it by a factor half. Okay? So it has expanded. It is a first, before it was existing from minus 8 to 5. Now it is existing from minus 16 to 10. Okay? So our signal has expanded and we have done that. Now what we have to do is we have to amplitude scale it. Okay? So for amplitude scaling, you have 3 times x of n by 2 plus 1. So what happens now? What happens to the signal, guys?
Amplitude is multiplied by 3.
3, right? So at 0, what you have? At 0, you have 1. So 1 into 3 will be, at 0, it will be 3. At 2, it will be
6,
at 2 it will be 6. At 3 it will be
9,
at 4.
12,
At 5,
15,
15. At 6,
18,
it will be 18. Okay. It will be 18. At -1, sorry, at -2, it will be 0 only. At -4,
minus 18, ma'am.
it will be -18.
Excuse me, ma'am.
Yes.
Here it should be like 2, 4, 6, 8, and 10, right, ma'am?
Where?
At n line, ma'am. N axis.
-2, -4, -6,
In
-8.
Ma'am, positive.
Okay. At 2, 4, 6, 8, 10. I'm sorry. So at -4, it will be. What is the amplitude at -4?
Minus 18,
-18. At -6, how much it is?
minus 18,
-18. At -8,
plus 18,
it is +18. At -10,
minus 12,
-12. At -12,
minus 9,
-9. At -14,
minus 6,
-6. And at -16,
minus 3.
-3. Got it, everyone? Understood?
Ma'am, in test and exams, we need to write each and every step, ma'am, or if you get idea, we can directly write last paper.
Better you write each and every step.
Okay.
Scaling one step, shifting one step, and last amplitude scaling one step. Okay?
Okay.
Got it, everyone? Understood this problem?
Ma'am, can you move a little bit on the right? Ma'am? Yes.
Followed? Did you guys follow?
Yes, ma'am.
So now we shall see one more type of problem. So that is express x of t in terms of g of t. Okay. So they'll give you x of t and g of t, and they're asking you to express x of t in terms of g of t. So we shall see what is x of t first. So 1, 2, 3, 4, 5. Instant 1, 2, and 3. So from 0 to 2, the amplitude is 3. Then again from 2 to 4, the amplitude is 2. And again from 4 to 5, the amplitude is 1. Sorry, I have done wrong. So from 2 to 3, it changes. And from 3 to 5, the amplitude is 1. Okay, this is the x of t. Okay, here it is 2, here it is 1. So next, I will show what is g of t. G of t is a signal which is step signal. Okay. from 0 to 3 with an amplitude 1. So what they are asking you is, you have to express x of t in terms of g of t. Okay, the x of t is extending from 0 to 5, correct? The signal is existing from 0 to 5 and this is from 0 to 3. Okay, so x of t is existing from 0 to 5. Okay, it has amplitude of 3 from 0 to 2. It has amplitude of 3 and it has amplitude of 2 from 2 to 3. Okay, and it has amplitude of 1 from 3 to 5. Okay, this is my x of t and my g of t is just a signal. It is extending from 0 to 3 with an amplitude 1. So I have to express x of t in terms of g of t. Okay, so now if I slice this up horizontally, this x of t, I'll get 3 waveforms, right? I'll name it as g1 of t, g2 of t and g3 of t. Okay, x of t I'm slicing horizontally and I'm naming it as g1 of t, g2 of t and g3 of t. Okay, as you can see. So g1 of t is a signal which is existing from 0 to 5 with an amplitude 1. Okay, this is first slice. Okay, I'm cutting this horizontally. This is one part, this is one part and this is one part. So next I have g2 of t. So g2 of t extends from where to where?
0 to 3, ma'am.
0 to 3. Okay, with an amplitude 1. And I have g3 of t. And I have g3 of t. 1 minute, I'll write the time instance. So I have g3 of t which is extending from 0 to 2 with an amplitude 1. Okay, so we have divided x of t in three signals. Okay, we have sliced it horizontally and we are expressing in terms of 3 signals, g1 of t, g2 of t and g3 of t. This is extending from 0 to 2 with an amplitude of 1. Okay, I can split x of t into g1 of t, g2 of t and g3 of t. Okay, this part from 0 to 5. Okay, 3, 4, 5. Yeah, this is one g1 of t. This part.
What about the amplitudes now?
Amplitudes is 1 only. 1, 1, 1.
Ma'am, but there we have given like 1, 2, 3, no ma'am, amplitude.
Yeah, if I cut this, this is only amplitude 1, right, from 2 to 3.
Okay, ma'am, I got it.
So now if I cut this, I have from 1 to 2, that is amplitude is 1. Again from 0 to 1, amplitude is 1. Got it?
Yes, ma'am.
So can you observe g of t and g2 of t are same? Yes or no?
Yes, ma'am.
G of t is same as g2 of t. Okay. Now I have to express x of t in terms of g of t. What I did is x of t I split it. g1 of t plus g2 of t plus g3 of t. I have to express x of t in terms of g of t, right? So what I have done is I have split x of t into g1 of t, g2 of t, g3 of t. So this g2 of t directly I can write g of t only. So g1 of t I have to write in terms of g of t. So what do we do? How do we express g1 of t in terms of g of t? So what shall we do?
In the time axis, ma'am.
So how do we scale it?
Ma'am, n plus 2.
Just think about it. How can we scale it? This is g of t. Okay. So what I'll do is I'll scale it to 1. Okay. So I'll compress the signal to 1 and then I can expand it to 5. So how do I compress this g of t to 1?
Divide time axis by 3.
Yes, it should extend from 0 to 1. Did you understand what I am doing? So this g of t, first I will scale it. G, 1 minute. G 3t, correct? If I scale it with an integer, that is 3, I'll have a signal from 0 to 1 with an amplitude 1. Yes or no?
Yes, ma'am.
So what I have done is I have scaled it with an integer 3 to compress my signal, which was at 3 to 1. Okay. Now I want G1 of t. So what can I do now? I want to expand it to get from 0 to 5. So what can I do?
I'm again scaling.
Yeah, G 3 by 5t can I do? I'm scaling it by 0.2. Got it, everyone? My signal will go up to 5 now. 1, 2, 3, 4, 5 with an amplitude 1. Understood?
Yes, ma'am.
Got it? So I can express G1 of t in terms of G of t as G3 by 5t. Correct? Yes or no, guys? Now I want to express x of t in terms of G of t. Correct? Now I got G2 of t is directly G of t. G1 of t is G3 by 5t. Correct? What I am doing is this G of t, I am compressing it by scaling it by a factor 3. So whatever is at 3 will come to 1. It will get compressed. Now again I am expanding this signal to get this. Till 5 I have to get. So what I am doing, I am scaling it by a factor 5. So 1 by 0.2, what do you get? 1 by 5 is 1 by 0.2, right? 1 by 0.2 means it will go up to 5. The signal will expand up to 5. Got it, everyone? Or 3t by 5. Okay? Got it?
Yes, ma'am.
Understood? So my first, I have expressed G1 of t and G2 of t in terms of G of t. Now I have to go to G3 of t. Now I have to express this in terms of G of t. So how do I do that? So this is the first one. This is the second
G
one.
of 3 by 2t.
Correct. So first what you have to do is G3 of t. I want to write G of t in terms of G3 of t. Now what I have to do is G of t, I'll scale it to 3t. Okay. So if I scale it to 3t, so whatever this signal is G of t. Correct? 1 minute. So that will come and compress, right? It will come to 1. 0 to 1 with an amplitude 1. Now I want a signal from 0 to 2. Correct? So now I'll scale it 3t by 2. G of 3t by 2. So whatever is at 1 will go to 2. Got it, everyone? Understood? Clear, everyone? So now I will start expressing my x of t in terms of g of t. So x of t is equal to g1 of t plus g2 of t plus g3 of t. What is g1 of t? G 3t by 5 plus g2 of t is g of t only because it's the same. And what is g3 of t? G 3t by 2. Got it, everyone? Followed?
Yes, ma'am.
Clear everyone? So I have written x of t in terms of g of t. I have expressed x of t in terms of g of t. This is how you have to do. Clear?
Yes, ma'am.
Everyone, it is clear? So we will see one more problem of such type. So if you want me to explain once, I'll explain once. So they're telling you to express x of t in terms of g of t. They have given you x of t and g of t also. You have to express x of t in terms of g of t. This signal you have to express. So what we are doing is we are slicing x of t horizontally. Okay. So we get g1 of t, g2 of t and g3 of t. g1 of t is a signal from 0 to 5 with an amplitude 1. g2 of t is a signal from 0 to 3 with an amplitude 1. And g3 of t is a signal from 0 to 2 with an amplitude 1. Okay, we have separated that. Now we have to write everything, this g1, g2 and g3 of t with respect to g of t. So we can see that g of t is same as g2 of t. It is extending from 0 to 3. Both are extending from 0 to 3 with an amplitude 1. So g2 of t is nothing but g of t. Okay. Next, we have to express g1 of t in terms of g of t. So how do we do that? So g of t is a signal from 0 to 3. g1 of t is a signal from 0 to 5. So how to express g1 of t in terms of g of t is, first we will scale, we'll try to get it to, we have till 3, but we want a signal till 5. So first we will scale this and get it to 1. So how do we scale it? If we scale it by an integer, then you can get it, you can compress that signal, correct? When you are scaling it by an integer, the signal will get compressed. Okay. So if I scale by 3t, whatever is at 3 will come to 1, correct? Divided by 3 here. So the signal will come from 0 to 1 with an amplitude 1. Now I want this signal. It will be easy for me to expand if it is from 0 to 1. So again, if I scale it by an integer, the signal will go to 5. Okay. So I am scaling it by a fraction, that is 1 by 5 or 0.2, so that it will get expanded and go up to 5. Got it everyone? 3t by 5 or 3 by 5t, you will get a signal from 0 to 5 with an amplitude 1. This is our first waveform g1 of t. We are done with that, and g2 of t is nothing but g of t only. Coming to g3 of t, I want to express g of t, g3 of t in terms of g of t. So what I will do, same thing, this I will compress it from 0 to 1. The 0 to 1, how do you compress? By scaling it by a factor 3. Now again, I want a signal from 0 to 2. So what do? I'll expand by a factor 0.5 or half. So it is 3 by 2t. So a signal is existing from 0 to 2 with an amplitude 1. So x of t is addition of g1 of t, g2 of t, g3 of t. So g1 of t we can write it as g3 by 5t or g3t by 5 plus g of t plus g3t by 2. Got it everyone? Expressing x of t in terms of g of t. Clear? I'll give you one more signal similar to that. Try that. Express x of t in terms of g of t. So x of t is similar staircase signal 1, 2, 3. So this is 1, 2, 3. So from 0 to 1 it is 1. Again it's going to 2 at instant 2, and it's going to 3, amplitude 3 at instant 3. Okay, this is your signal x of t, and g of t is similar, but it's in both the axes, -1 to +1, -1 +1. Okay, so now what will you do? What is the first step?
Scaling g of t to 0 to 1.
Yeah, first, yeah, we will do that. We'll try to get our signal from 0 to 2. Okay, because it's better to have a signal from 0 to 2 instead of -1 to 1. Okay, we will do that next step. What is first step? you have to express x of t in terms of g of t. So you slice it horizontally. Okay, so your signal will be from 1 to 3 with an amplitude 1, 1 to 0 to 3 with an amplitude 1, 1 to 3 with an amplitude 1, and 2 to 3 with an amplitude 1. Okay, so I will write the different waveforms of x of t in terms of g1, g2, and g3 of t. So g1 of t is a signal from 0 to 3, 1, 2, 3 with an amplitude 1, and g2 of t is a signal which is existing from 1, 2, and 3 with an amplitude 1. Okay, and g3 of t is a signal which is existing from 2 to 3 with an amplitude 1. Got it, everyone? I am cutting this signal horizontally. Okay, this is one part, this is one part, and this is one part. I am expressing it as g1 of t, g2 of t, and g3 of t. Got it, everyone? Is it clear?
Yes, ma'am.
Now what you have to do is, g of t is existing from -1 to +1. It is better if we have our signal existing from 0 to any other value. So I will shift it. So how do I shift it? G of t -1. Okay. So that my signal will be shifted to the right by 1 instant. Okay. Whatever is at -1 will go to 0. Whatever is at 0 will go to 1. And whatever is at 1 will go to 2 with an amplitude 1. This is amplitude 1, amplitude 1. You have got g of t -1. Okay. Now what you will do? Now we have to try to get g of t -1 in terms of g1 of t, g2 of t, and g3 of t. Okay. So what is the first step? To get g1 of t in terms of g of t -1, what do we do? Whatever we did previously, same thing we will do. Okay. So you have g of t -1. You have to express that in terms of, you have to express g1 of t in terms of g of t -1. What do? You will scale this to get from 0 to 1, then you will expand it to get from 0 to 3. Got it? Got it, everyone?
Yes, ma'am.
So what do you do? G of, to compress it from 0, compress this signal from 0 to 1, what do you do?
2t by 3.
Yeah, 2t by 3 -1, correct? So first we will try to get it from 0 to 1. Okay, so for that we have to do 2t -1. So if I have to scale it by 2 divided by 2, I'll have. So it will exist from 0 to 1. Got it? So my signal is existing from 0 to 1 with an amplitude 1. Now I want my signal to exist from 0 to 3 because I want to express g1 of t in terms of g of t -1. Okay, so what do I do to get this signal from this? You'll scale it by a factor 3.
-1.
Yeah. So you will have g of 2 by 3t -1. Okay. 1 minute. Yeah. So I have g of 2 by 3t -1. So what I am doing is I am expanding my signal now, which is present from 0 to 1. I am representing that from 0 to 3. I am expanding my signal by scaling. 1, 2, 3. So this is my g1 of t. Okay, in terms of g of t. So this is my first signal. So for g2 of t, what do you get? So I have a signal from 1 to 3. G2 of t is a signal from 1 to 3. So what do we do to get this?
Shifting.
No, not shifting. So we
If we shift at G2, T -2, it will come, no?
g of t, you will shift it. Yeah, so but how to get this signal? How will you get this signal?
Ma'am, if we shift T to -2,
G of
Then
t minus 1 minus 1. That G of t minus 2, ma'am.
So how you can do is, one method I'll show you. You have uh, 0 to 3, you have one signal. Okay. This is, we have represented that in terms of g of 2 by 3t minus 1. That if I subtract this, will I get this? G of 2 by 3t minus 1 minus g of
Yes,
2t
ma'am.
minus 1. I'll get this. I'm subtracting this part, 0 to 1. Correct? Yes or no?
Yes, ma'am.
So I have g 2 by 3t minus 1 minus g of 2t minus 1. So see the amplitude. At 0, you have 1 and 1. So you get 1 minus 1, it is 0. And at 1, you have 1 is going to 0 and here it is 1. So you get 1. At 2, it is 0. Sorry, at 2 it is 1. 1 minus 0, it is 1. At 3, it is 1 minus 0, it is 1. Got it?
Excuse me, ma'am.
Yes.
Ma'am, in this like G1, we have to match this with the G signal, no, ma'am, like G of t minus 1.
So you see, we want to express x of t in terms of g of t. Okay. So we have divided x of t into g1, g2 and g3. So can we do like this to get this signal from 1 to 3, or you can shift this also. Okay. Clear? What I am doing is I am subtracting this minus this to get this one, a signal from 1 to 3. Because I have to have everything in terms of g of t only. G2 of t should be in terms of g of t, and G3 of t also should be in terms of g of t. Got it?
Yes, ma'am.
So now G3 of t, you tell me. So how do you get G3 of t? G3 of t, can you obtain it by this one? G of 2t, 2 by 3t minus 1 minus g of t minus 1. Yes or no? You have a signal from 0 to 3. If you subtract this from 0 to 2,
From
what do
1
you get?
to 3 can do g of t minus 2.
G of t minus 2.
2 minus 2.
If you do g of t minus 2, from where to where will your signal exist? It is here 2 instants, correct? But we want only 1 instant here. From time instant
All the from
to
previous one.
what?
Signal from 1 to 3. G2 of t.
Yeah. This is G2 of t, correct?
G2 of t we can write as g of t minus 2.
G of t minus 2. Just a minute. If you write g of t minus 2, that signal will be existing from,
1 to 3.
but you want from 2 to 3.
Not that my previous one I am telling G2 of t. That one I am telling you written the two equation. Instead of that we can write g of t minus 2.
G of t minus 2. Yeah, it will exist from 1 to 3. Correct. You can do like that also. Okay. So now we are thinking about G3 of t, that you can write. Okay. G of t minus 2 also you can write. And we are thinking about G3 of t. So how do you get this G3 of t? This minus this. Correct. This waveform minus this waveform, you'll get G3 of t. We have got G1 of t Okay, this is your G1 of t. This is your G2 of t. Now to get G3 of t, can I write like this? G of 2 by 3t minus 1 minus G of t minus 1. If we subtract this and this, will we get a signal from 2 to 3
Yes, ma'am.
with an amplitude 1? Got it? So we are subtracting this. This signal is existing from 0 to 3 with an amplitude 1. This is existing from 0 to 2 with an amplitude 1. So at 3, what is the amplitude? 1 minus 0, you get 1. Okay. So now we'll write collectively x of t is equal to G1 of t. Yes.
Ma'am, for the G3 of t, we can write as G of 2t minus 3, ma'am.
G of 2t minus, yes, you can write like that also. Yes, you can express like that also. Okay, G1 of t plus G2 of t plus G3 of t is nothing but G of 2 by 3t minus 1 plus G of 2 by 3t minus 1 minus G of 2t minus 1 plus G of 2 by 3t minus 1 minus G of t minus 1. Correct? These 2 by 3 terms you have 3. So we'll get 3 times G of 2 by 3t minus 1. Okay. You can write like that also. Okay. You can express, but it should be correct. Okay. That scaling should be done correctly. Then you can express in that form also. So this will be 3 times G of 2 by 3t minus 1 minus G of 2t minus 1 minus G of t minus, it is t minus 1, no? It is t minus 1. Okay. Got it, everyone? Is it clear? Now I have expressed x of t in terms of g of t. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so this is one problem. And one more problem. So this is in terms of x of t in terms of g of t. Okay. I'll give you one problem for homework. You try that. Homework problem. Express x of t in terms of g of t. Okay, so here x of t is similar. Okay, it is 3, 2 and 1. So this is 3, this instant is 2 and this instant is 1 with an amplitude. This is 1, this is 2 and 3. This is your x of t, and g of t is a signal which is existing from 0 to 2 with an amplitude 1. You try this, okay? So this type of problem is we are done expressing x of t in terms of g of t type of problems. So next we'll see plotting, okay, in terms of RAM. So next type of problem is plot y of t, which is equal to r of t plus 1 minus r of t plus r of t minus 2. You have to plot this waveform.
By vertical slicing, ma'am.
What?
The above problems can be done by vertical slicing also, ma'am.
But it will be little complicated if you do vertical slicing. Do horizontal slicing only, because you have g of t in that form only, right?
Okay, ma'am. We can do no, ma'am.
If you do, it will be little complicated.
Okay, ma'am.
Okay, you can try that if you want.
But signal will be different, no, ma'am, that equation.
Yes, that's all. Yeah, will it be different? You just try, okay? I haven't tried vertical slicing. You try and you let me know. So we are given to plot y of t which is r of t plus 1 minus r of t plus r of t minus 2. What type of signal is this? R of t?
Ramp, ma'am.
R of t is a ramp signal. Okay. So what is the definition for ramp? What is the definition for ramp signal? So at 0 it is 0, at 1 the amplitude is 1, at 2 the
3 into
amplitude is 2, at 3 the amplitude is 3, so it goes on up to infinity. This is R of t. Okay, what is the definition of R of t? It is t for t greater than or equal to 0, it is 0 otherwise. Okay, this is the ramp signal. So you have r of t plus 1 minus r of t plus r of t minus 2. So how do we plot this signal y of t? First you write what is r of t plus 1, r of t and r of t minus 2. So r of t plus 1, how will that signal look? R of t plus 1, k is positive, so it is
It will exist
From
as
minus
-1.
1.
k is positive, so it is right shifting or left shifting?
Left.
Left shifting, ma'am.
Left shifting. At what instant my signal will start?
-1.
At -1 the signal will start. Okay. So at 0 it is 1. At 1 it is 2. Amplitude is 2. And at instant 2 the amplitude is 3. Okay. At instant 3 the amplitude is 4. At instant 4 the amplitude is 5. Got it? Understood? It is clear, no? Yes or no?
Yes, ma'am.
So R of t means the signal will start from 0. R of t plus 1 means k is positive, so left shifting. So my signal is occurring 1 second earlier. It's starting from -1. Okay, at 0 the amplitude is 1, at 1 amplitude is 2, at 2 amplitude is 3, at 3 amplitude is 4, at 4 amplitude is 5. Okay, this is R of t plus 1. And I have R of t. R of t is our ramp. Okay, at 1 the amplitude is 1, at 2 the amplitude is 2, at 3 the amplitude is 3, at 4 the amplitude is 4, and at 5 the amplitude is 5. It will go on up to infinity. Okay, this is 1, 2, 3, 4 and 5. Okay, 4 and 5. Next we plot R of t minus 2. R of t minus 2. So what type of signal is that? R of t minus 2? You have shifting. So t minus 2. So from where will the signal start?
+2.
It will start at +2.
It will start at +2, correct? So my signal is starting from +2 because you have k negative. So it is occurring 2 seconds late. So it's starting at 2, which was about to start from 0. It is starting at 2. Okay, this is my signal. At 3, the amplitude is 1. At 4, the amplitude is 2. At 5, the amplitude is 3. And at 6, the amplitude is 4. Okay, do this much. Now we have to evaluate the signal. Okay, we have to get this equivalent waveform y of t. So you observe here
Ma'am.
R of t plus 1 minus R of t plus R of t plus 2. This is the equation we have, correct?
Ma'am, go a little bit slow, ma'am.
Yeah. Is it very fast?
Yes, ma'am. 1 second, we are writing.
Okay. So you have given, they're telling you to plot this signal y of t, which is R of t plus 1 minus r of t plus r of t minus 2. Okay, you people know what is the equation for ramp signal, definition of ramp signal. It is t for t greater than or equal to 0, it is 0 otherwise. Okay, r of t is equal to t means at t is equal to 0, it will be 0. At t is equal to 1, it will have amplitude 1. At t is equal to 2, amplitude will be 2. At t is equal to 3, amplitude will be 3. It will go on up to infinity. Clear? R of t plus 1 is shifting. It is left shifting by 1 instant. Okay, so my signal is starting from minus 1. Okay, if it started minus 1, what is amplitude at 0? It is 1. At 1, it is 2. At instant 2, it is amplitude is 3. At instant 3, amplitude is 4. At instant 4, amplitude is 5. Got it? And R of t is as usual. It will be t. At 1, amplitude will be 1. At t is equal to 2, amplitude will be 2. So this is time axis. So at 3, it will be 3. At 4, it will be 4. At 5, it will be 5. Okay, because it's normal R of t. So R of t minus 2 will, it is shifting. Okay, k is negative and it's right shifting. Okay, so we are shifting R of t by 2 instants. Okay, right, because k is negative. The signal is starting from 2. So if the signal starts from 2, at 2 amplitude will be 0. At 3 the amplitude will be 1. At 4 it will be 2. At 5 amplitude is 3 and at 6 amplitude is 4. Everyone clear?
Yes, ma'am.
You need some more time to understand? Is it clear, guys?
Yes, ma'am.
Okay, so shall we start to plot the waveform y of t? Are you taking down? You want some time?
No, ma'am, finish.
Done? Okay, so we will try plotting this signal. We have r of t plus 1 minus r of t plus r of t minus 2. Okay, I will go slow now. You people try to listen here. I'll draw our original waveform. This is y of t, which we have to plot now. That is nothing but r of t plus 1 minus r of t plus r of t minus 2. Okay, I'll write it. R of t plus 1 just a minute. So y of t is nothing but r of t plus 1, okay, minus r of t plus r of t minus 2. Okay, you evaluate from instant. So the interval between minus 1 to minus 0, what you have in all the waveforms, you check. Okay, the interval from minus 1 to 0, in this you have a ramp. Okay, you have a ramp signal going from 0 to 1. Here you don't have anything. Here also you don't have anything. So from minus 1 to 0, you will just have that ramp. Okay, got it? Between minus 1 and 0, I have a ramp signal here. Here I don't have anything. Here also I don't have anything. So this minus 0 plus 0 would be the same ramp only. So I have a ramp here. Okay. Now at 0 you see what you have. At t is equal to 0 or at t is equal to 1, we shall see. So at t is equal to 1, what is the amplitude?
2, ma'am.
At t is equal to 1, amplitude is 2. Here at t is equal to 1, what is the amplitude?
1.
1. Here what is the amplitude at t is equal to 1?
0.
0. So at t is equal to 1, in my first signal I have amplitude 2, in second signal I have amplitude 1, and third signal the amplitude is 0. So what will be the amplitude at 1?
1.
It will be 1 only. Got it? Following? I'll explain once again. At t is so we have done the left part from -1 to 0. We have done. We have a ramp signal from -1 going to 1. So this is a ramp from -1 to 0. You have a ramp going to 1. Here we don't have anything, correct? So write it as it is. Next, because we have r of t plus 1 minus r of t plus r of t minus 2. Okay, we don't have any signals here, so no need of any operation. So at t is equal to 1, you see now. Amplitude is 2. Okay, I have written 2 here. R of t plus 1, it is 2 at instant 1. Then here it is what at t is equal to 1, what is the amplitude? It is 1. So -1 plus at 1, you have 0 here. Okay. So at t is equal to 1 only I am evaluating. Okay. Observe carefully. At t is equal to 1, it is 2 minus 1 plus 0. The amplitude is 1 at t is equal to 1. Now we shall see at t is equal to 2. Okay. At t is equal to 2, what is the amplitude in first signal? At t is equal to 2, what is amplitude here?
3.
3.
It is 3. Minus here in this signal, what is amplitude at 2?
2.
2. Plus in this signal, what is amplitude at 2? It is 0. Plus 0, it is equal to 1 only. At 2 also it will be 1. At 2 instant it will be 1 only. We'll go to 3. At t is equal to 3 instant. What is the amplitude here in first one?
3.
At t is equal to
No, 4.
4. Correct. 4 minus in this signal
3.
at t is equal to 3, it is 3. Plus at this signal at 3, what is the amplitude?
1.
1. So what is our amplitude? 4 minus 3 is 1. 1
2.
plus 1, it is 2. So you have the amplitude 2 at 3. Okay, we'll evaluate at 4. Okay, so at t is equal to 4, I will write this side. So what is the amplitude here?
5.
5 minus at 5, what is t is equal to 4, what is the amplitude here?
4.
4 plus at 4, what is the amplitude here?
2.
2. So what do you have? What do you get? 3.
3 more.
At 4, it will increase 1 instant. It will go to 3. And at 5, we'll evaluate. Okay, at t is equal to 5. Again, what you have here?
6.
T is equal to 5. In first signal, you have amplitude 6. Second signal, 5.
5.
Third signal,
3.
plus 3. What do you get?
4.
4. So this signal will go on up to infinity. Got it? Got it, everyone?
Yes, ma'am.
After t is equal to 2, the signal will go on. It will be increasing its amplitude 1 instant. It will go up to infinity. Okay, so this is the waveform. Is it clear? Is it clear, everyone?
Yes, ma'am.
Did I go fast? Want me to explain once again? Guys, you want me to explain once again?
No, ma'am.
What about others?
No, ma'am.
If you want me to explain, I'll just explain once again, briefly. Okay, so see here. You have to plot y of t, which is r of t plus 1 minus r of t plus r of t minus 2. Better if you do like this, it will be helpful. Okay, so first plot what is r of t. R of t is equal to t. Okay, at t is equal to 1, it will be equal to 1. At 2, it will be equal to 2. At 3, it will be equal to 3. It will go on up to infinity. That is the definition of ramp signal. Okay, it is t for t greater than or equal to 0. It is 0 otherwise. Okay, this is a ramp signal. So we are told to plot this signal r of t plus 1 minus r of t plus r of t minus 2. So r of t plus 1 is a shifted version of r of t. So k is positive here. If k is positive, we have left shifting and the signal is occurring 1 second earlier, which is starting from 0, will occur 1 second earlier at minus 1 only. This is the shifted version r of t plus 1. Okay. Then r of t minus 2, here you can see k is negative. Okay. K is negative means it is right shifting and the signal is occurring 2 seconds late. So it's starting from 2. The ramp signal, same ramp signal, is starting from 2 here, starting from minus 1 here. You can observe it is shifting with respect to ramp signal. So they have told us to plot r of t plus 1 minus r of t plus r of t minus 2. So to make it easy, what you have to do is you take the amplitudes at each instant. Okay, what is amplitude? You check at each instant and write down that in the y-axis. So it will be easy for you to do. Okay, so evaluate from one instant to one instant. You have to subtract r of t from r of t plus 1 and you have to add r of t minus 2. So at each instant you be doing like that. So from minus 1 to 0, we just have a ramp here. Here we don't have 0, nothing we have. So we have the same thing here from minus 1 to 0. At 1, you see what we have. At 1 here, the amplitude is 2 here. Okay, at 1 in this signal, the amplitude is 1. And at 1 at this signal, amplitude is 0. So 2 minus 1 plus 0 is 1 only. So at instant 1, it will be 1. Okay, now at t is equal to 2, you check. Okay, at t is equal to 2, the amplitude is 3 here. Okay, here at t is equal to 2, it is 2 only. At t is equal to 2, here it is 0. Okay, so 3 minus 2 plus 0 is 1. So at instant 2 also it will be 1 only. Okay, now you evaluate at instant 3. At instant 3, here the amplitude is 4, here it is 3 and here it is 1 at 3. Okay, so it is 4 minus 3 plus 1. So at 3, you will get 2. Correct? So the amplitude will go up by 1 instant at 2. Okay. So at t is equal to 4, similarly, check the amplitude at each instant. At 4, the amplitude will be 5. Okay. Here at 4, it will be 4 only. At 4, here it is 2. So 5 minus 4 plus 2, it is 3. So it is increasing. So after t is equal to 2 seconds, it will be increasing and it will go up to infinity. So if you show some 2 instants or 3 instants after that, it's enough. Okay. Clear, everyone? Is it clear?
Yes, ma'am.
I'll give you one homework problem of this type. You try it. Try that. Okay. So you have y of t is equal to r of t plus 2 minus r of t plus 1 minus r of t minus 1 plus r of t minus 2. You try this, okay, and we will discuss this tomorrow in tomorrow's class. Okay, you try this, it's easy only. So we have, and you have such signal y of t in terms of u of t also. I will do that tomorrow in tomorrow's class. Okay, in u of t also have u of t minus 3 plus u of t minus 2, something like that. Okay, so no need of this now. I'll do this tomorrow, plotting in terms of unit step. Now today you understand about ramp signal and try that. And I'm left with even and odd signals, right? Even and odd signals in terms of discrete time signal. Okay, we shall see that now. So if you want 5 minutes break, you can take a break and we'll continue. You want 5 minutes break?
Yes, ma'am.
Okay, you can
Yes,
take
ma'am.
5 minutes break and get back. Okay. Shall we start? Shall we start our class?
Yes, ma'am.
What about others?
Yes, ma'am.
Yes, ma'am.
Are you guys there? Okay, guys, we'll start. We'll continue with our problems on even and odd signals of discrete time. So take down the question. Find and plot even and odd components of the following discrete time signals. Okay. So what is the even component of x of n? X e of n, what is the even component equation?
x of n plus x of minus n divided by 2.
Yes, x of n plus x of minus n divided by 2. This is the equation for even part of the signal, the even component or even part of the signal. X o of t, x o of n is odd component of the signal. Okay. So what is the equation for this?
X of n minus x of minus n divided by 2.
X of n minus x of minus n divided by 2. In continuous time signals, you have x e of t, right? It is x of t plus x of minus t by 2. Whereas odd component of t was, odd component of a signal was x of t minus x of minus t by 2, right? This is with respect to discrete time signal. This is with respect to continuous time signal. Okay. So what you have to do to get even part of the signal? If you have signal x of t, x of n, you have to time reverse that. Okay, you have to find out x of minus n, then add both the signal, then scale it. Okay, scale the amplitudes. Similarly, for odd part, try to plot x of n and minus x of minus n, or x of minus n you plot time reverse part, subtract these, okay, and divide by 2. Divide the amplitudes by 2, so you get odd part of the signal. So we'll start with the first problem. So first problem is x of n is equal to u of n. What is u of n? What is u of n?
Unit step signal.
It's a unit step signal. The amplitude is 1 from n for n is equal to greater than or equal to 0. It is 0 for n less than 0 or otherwise. Okay. So how will your u of n look? It will be 1, amplitude 1 from 0 up to infinity. This is n axis. This is u of n, which is equal to x of n. Okay. So to find the even and odd part of the signal, you have to plot u of minus n, time reverse version of u of n. Okay. If you fold it about y-axis, what do you get? The signal will exist from where to where?
-1 to infinity. Sorry, 0 to infinity. This side.
So it will exist from minus infinity to 0, correct? So it will be at -1, -2, -3, -4, so on up to minus infinity. So this signal is existing from minus infinity to 0. This is existing from 0 to infinity. Got it? So now what we have to do is, you have even we have to plot even part. So it is u of n plus u of minus n by 2. Okay, first we'll add this, then we'll do scaling, amplitude scaling. Okay, so first u of n plus u of minus n, what you have at at n is equal to 0, what will be the amplitude? You have here also you have 1, here also you have 1. So at 0, what will be the amplitude?
2, ma'am.
It will be 2. Yes or no, everyone?
Yes, ma'am.
So at instant n is equal to 1, what will be the amplitude? 1 plus 0. Here you have 0, right, at plus 1. At 2 also you have 0. So here 1, at instant 1 you have 1 plus 0, it is 1. At 2 also you have 1. At 3 also you have 1. At 4 also you have 1. It will go on up to infinity. Okay, for negative values of n at -1, -2, -3, -4, what are the value of signal? At -1, what you have? Here you have 0 plus 1. Amplitude is 1, right? So 0 plus, here you have at -1 you have 0. 0 plus 1 would be 1. Again at -2 also you have 0 plus 1, so it is 1. At -3 also 1. At -4 also 1. Got it, everyone? You're following or not?
Following.
So now you divide by 2 to get even part. Okay, so that would be u of n plus u of minus n by 2. When you're scaling by a factor 2, what do you get? At 0, what will you have your signal amplitude?
1, ma'am.
At 2, you will have amplitude of 1. At 1, you'll have
0.5.
0.5. At 2, 0.5. At 3 also 0.5. At 4 also 0.5. It will go on up to infinity. Okay. Similarly, on negative side of n, that is -1, -2, -3, -4, so on up to minus infinity. So what will be your signal amplitude? If you scale it by a factor 2, it will be half, right? So here also it will be 0.5, 0.5, 0.5, 0.5, so on up to infinity. Got it? Understood, everyone?
Yes, ma'am.
Even component of u of n. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
So let us plot the odd component of u of n. So to plot the odd component, what is the equation? It is u of n minus u of minus n. So you have to subtract u of n minus u of minus n. At 0, what will be the amplitude?
0, ma'am.
At 0, you will have amplitude 0. At 1, what will be the amplitude? 1 minus 0. For all the positive values of n, what will be the amplitude? It will be 1 only. Because here you have 1. From 1 to infinity, it will be 1. Okay. So 1 minus 0, it will be 1 only. The amplitude will be 1. Five also 1, it will go on up to infinity. What about negative side?
-1.
Correct? It will be -1. So in u of n, you have at -1 you have 0. So 0 minus 1. Here you have 0. At -1 in u of n, the amplitude is 0 here. Correct? It is 0. Here you have 1. So 0 minus 1 would be -1. Okay, for all the negative values of n, the amplitude would be -1 only. Okay, So at -1 it's -1, at -2 it's -1, at -3 also it's -1, at -4 also it's -1, at -5 also it's -1. It will go on up to -infinity. This is u of n minus u of minus n. Okay, now if you scale it by a factor 2, what do you get? U of n minus u of minus n by 2. So what do you get? For positive values of n, the amplitude will be at n is equal to 0, it will be 0 only. For positive values of n,
0.5.
it will be 0.5. And for negative values of n,
minus
Minus
0.5.
0.5.
minus 0.5. Okay, here it's plus 0.5. For negative values of n, it is minus 0.5. Okay, this is minus half or minus 0.5. Got it, everyone? How to plot the even and odd part of the signal? Discrete time signal. So, clear, everyone? Are you people there?
Yes, ma'am.
Yes,
How
ma'am.
about others?
Yes, ma'am.
Okay. So you have been given a signal u of n, and you have been told to plot the even and odd part of the signal u of n. So take u of minus n, time reversed version of u of n. Then you add these two. If you add these two at n is equal to 0, you will have 2. Okay. For all other values of n, you will have 1. Okay. So if you scale that by a factor 2, the amplitude will be scaled by half. Okay. At 0, you'll have 1. Whereas all other values of n, you'll have half. This is the even part of the signal. Okay. You can take x e of n, or you can also take u e of n. Okay. And this is negative odd part. Coming to odd part, the equation is u of n minus u of minus n by 2. So first we'll do u of n minus u of minus n. Okay, check the amplitude at each instant. Okay, at n is equal to 0, you have 1 here and 1 here. 1 minus 1 will be 0. At n is equal to 0, you'll have 0. Okay. At n is equal to 1, the amplitude is 1 here, and here it is 0. So 1 minus 0 will be 1. Okay, so for all the positive values of n, the amplitude would be 1. And for the negative values of n, see here you have zeros here. For minus 2, minus 3, and all you have zeros, correct? So 0 minus 1 will be minus 1. So for all the negative values of n, the amplitude will be minus 1. Okay. So now you scale it. Scale the amplitudes. So we have got u of n minus u of minus n. For positive values of n, it is 1. At n is equal to 0, it is 0. For negative values of n, it is minus 1. If you scale this, the amplitude will be reduced to half. Correct? So wherever you have 1, you'll have 0.5. Wherever you have minus 1, you'll have minus 0.5. Got it, everyone? It's minus 0.5. Here it's plus 0.5. Got it? Clear? Yes or no?
Yes.
So take down next problem. X of n is equal to u 3 times u of n minus 2. So what all operations are there here? Shifting and amplitude scaling, correct? So u of n is a signal will start from 0. It will start from 0 and it will go up to infinity with an amplitude 1. What about u of n minus 2? From where will the signal start? Minus 2 or plus 2?
Plus 2.
Plus 2, ma'am.
Okay, so k is negative here, which is minus 2. So it is right shifting and the signal is occurring 2 seconds late. Okay, so at n is equal to 0, n is equal to 1, it will be 0. At n is equal to 2, it will start. Okay, it will be 1, 2, 3. It will start from n is equal to 2 and it will go on up to infinity with an amplitude 1. Okay, So you are being given 3 times u of n minus 2. So 3 times u of n minus 2 means how will the signal look?
Amplitude is multiplied by 3 times.
Yeah, amplitude, which is 1, is multiplied by 3. Okay. So the signal will start from 2 with an amplitude 3 and it will go on up to infinity. Got it, everyone? 3 times u of n minus 2. Yes or no?
Yes, ma'am.
So u of n is a signal which is starting at 0 with an amplitude 1 and it will go up to infinity. U of n minus 2 is shifted version of u of n. It is starting from plus 2 or it is occurring 2 seconds late because k is negative, it is right shifting, or the signal is occurring 2 seconds late. It's starting from 2. Okay. And 3 times u of n minus 2 means you are multiplying that amplitude with 3. So the amplitude was 1 throughout, right? So it will be 3. Got it? So now you have to plot the even and odd part of the signal. Okay, this is your x of n. X of n is equal to 3 times u of n minus 2. So to plot even part of n, you have to do x of n plus x of minus n by 2. To plot odd part, you have x of n minus x of minus n by 2. So start doing this. So you have x of n. This is your x of n. Now how to plot x of minus n. In x of minus n, from where will the signal start?
Minus 2 to minus infinity.
Yeah, minus 2. You are folding this about vertical axis. This is your x of n. If I fold it with respect to y axis, so I have a signal at minus 2, minus 3, minus 4, minus 5, so on up to minus infinity with an amplitude 3. Amplitude will be 3, okay, throughout. So this is the folded version of the signal or time reversed version of the signal. Now, what will be x of n plus x of minus n? So what do you have? X of n plus x of minus n. At n is equal to 0, you have 0. 0 plus 0, 0. At n is equal to 1, also you have 0. 0 plus 0, it is 0 only. At n is equal to 2, you have a signal with amplitude 3. So here you don't have any signal, okay? So it is, you have a signal at 2 with an amplitude 3. Okay, and at 3 also you have 3 here and you have 0 here. So it is amplitude is 3. So it goes on up to infinity with an amplitude 3. Left side, here at minus 1 you don't have any signal, minus 1, minus 2, minus 3 and all. Okay, so but here you have a signal. So 0 plus 3 is 3 at minus 2. So it will go on up to minus infinity. So we have plotted x of n plus x of minus n. Okay, just you add these two, you will get this one. Okay, add the amplitudes at each instant you will get, or directly by seeing also you can write it. Okay, now we have to scale it by a factor 2. What happens now to the amplitude?
1.5.
It will become 1.5. X of n plus x of minus n by 2 means the signal will be having amplitude 1.5 from 2. Okay, up to infinity. So it will be having 1.5. It is scaled by a factor 2. 1.5, 1.5, 1.5. Okay, again from minus 2, minus 3, minus 4, minus 5, the amplitude will be 1.5 because it's scaled by a factor 2. Got it, everyone? Understood? Amplitude is getting half. Okay, so we will see x odd part, that is x of n minus x of minus n. Okay, so x of n minus x of minus n means you have to subtract this from this. Okay, x of n minus x of minus n. So 3 minus 0 is 3 only. So from 2 to up to infinity it will be 3 only. Okay, whereas from minus 2 to infinity it will be 0 minus 3. Here amplitude is 0, here it's 3. So 0 minus 3 it will be minus 3. Okay. So at minus 2 it is 3 only. Sorry, plus 2, plus 4, 5. It is 3 amplitude. For negative values from minus 2, minus 3, minus 4, minus 5, it's minus 3. Got it? 0 minus 3 is minus 3. Now if you scale it by a factor 2, what do you get? The amplitude will be reduced to half. Okay, it will be 1.5. That's all. Is it clear, guys? You're following or not?
Yes, ma'am.
So you have x of n minus x of minus n by 2. So amplitude at 2 and minus 2 will be scaled to half. Okay. Minus 3, minus 4, so on up to infinity. So here the amplitude will be 1.5. So from minus 2 to up to minus infinity, the amplitude will be minus 1.5. Got it, everyone? Followed?
Yes, ma'am.
You have any doubts? So I'll give you one more signal. Did you follow how to plot the even and odd part of the signal?
Yes, ma'am.
It is simple, right? Is it difficult? So x of n is equal to 2, 3, 4, 5, 6. So how do you plot this signal?
Ma'am, at 0 it will be 4.
At n is equal to 0, amplitude will be
4.
4. Then
At 1 it will be 5.
at 1 it is 5. At
At
2,
2 6. At minus 1 3.
3.
At minus 2 2.
At minus 2, 2. Got it, everyone? So we have to plot the odd and even part of the signal. So if we time reverse that, x of minus n. So you are folding the signal about y-axis or vertical axis. Okay, you are folding in between. So if you fold, what is there at 0 will be there at 0 only. Okay, what is there at 1 will be 3. What is there at 2 will be 2. At minus 1 it will be 5. And at minus 2 it will be 6. Okay, this is the time reverse version of x of n. Now you add these two, x of n plus x of minus n. So x of n plus x of minus n, what do you have? At n is equal to 0, 1, 2, 3, minus 1, minus 2, minus 3. So what do you have? At 0, amplitude?
Eight, ma'am.
At 0, the amplitude is 8. At 1?
8.
At 1 also it is 8. At 2?
8, ma'am.
At 2 also it is 8. At minus 1?
8.
8. At minus 2? Also it is 8. So if you scale it by 2, amplitude will get reduced to half. Got it? Divide by 2, you'll get 4. That is the even part of the signal. Got it? Got it, everyone? You get a signal with an amplitude 4. X of n plus x of minus n by 2 will be 4 from minus 2 to plus 2. Got it? This is the even part of the signal, x e of n. So how do we plot odd part? X of n minus x of minus n. First we'll plot x of n minus x of minus n, then we'll scale it. So if you have to plot x of n minus x of minus n, what will be the signal at 0?
0, ma'am.
At 0 it will be 0 only. At 1?
2.
It will be 2. And at 2?
4.
It will be 4. Okay. What about minus 1?
Minus 2.
It will be minus 2. And at minus 2 it will be?
Minus 4.
Minus 4. Understood, everyone? So at 0 you have 4 and 4. This minus this will be 0. And at 1 you have 5. And here at 1 you have 3. So 5 minus 3 it is 2. And at instant n is equal to 2 you have 6. And 6 minus 2 it will be 4 at 2. At minus 1 you have 3. So 3 minus 5 would be minus 2. And at 2 minus 2 you have 2. So 2 minus 6 would be minus 4. Okay, this is x of n minus x of minus n. Now we will scale it by a factor 2. So if you scale it by a factor 2, so the amplitude gets half. Okay, it will become half. So at 1 you'll have amplitude 1 and at 2 you'll have amplitude 2. So if you have x of n minus x of minus n by 2 would be at 1 you'll have amplitude 1, at 2 you'll have amplitude 2. Whereas for minus 1 you'll have amplitude minus 1 and at minus 2 you'll have amplitude minus 2. Got it?
Yes, ma'am.
Did you follow? So I'll give you 2 homework problems, you try that. Okay? Plot the even and odd part of the signal. Okay? So x of n is equal to alpha to the power of n into u of n, where alpha is a value between 0 to 1. Okay, you take alpha as 0.5 or 0.75. Okay, and plot the signals. Second one is a signal x of n is equal to cos pi by 2 n into u of n. Okay, so what is the meaning if you have u of n? If you have u of n in the question, that means the signal will exist from 0 up to infinity. Okay, so you can do this. You can find the even and odd part of the signal. Okay, you try this and we can verify these signals. Okay, you have any doubt? Is it clear, everyone?
Yes, ma'am.
So we have almost completed this unit 1. Okay, we have just a few problems here and there. I will search those problems and try to solve it tomorrow. Okay?
I'm sure the problem.
Yeah. Plot the even and odd part of the signal. Alpha to the power of n into u of n, where alpha lies between 0 to 1. You can take it as 0.5 or 0.75. Okay. And second one is x of n is cos pi by 2 n into u of n. Okay. Substitute the values of n and plot the signal. N is equal to 0, n is equal to 1, 2, like that. You can go on plotting. Got it?
Yes, ma'am.
So some more remaining problems I will solve in tomorrow's class, and you people try solving problems from textbook. Okay. So tomorrow I'll complete your unit 1. We are left with some more problems here and there. I'll just check if I'm left out with something, and I'll solve in tomorrow's class. You can write your name and USN in the chat box. You want me to repeat any topics? Or everything is clear? If you want me to repeat any topics, I'll repeat it in tomorrow's class. You can tell me now only. You want me to
in this chapter only problems they will ask, no ma'am?
Yes, only problems.
Okay, ma'am.
So we have seen different types of classification of signals, right? So, and operations on signals, correct? So classification of signals, we have seen discrete time, continuous time. That is basic classification, okay? You'll be solving problems on periodic, non-periodic signals. You have periodic, non-periodic signals, even and odd signals, and which is which is the other one? Energy and power signals. Okay, those three classification has problems: periodic and non-periodic, even part and odd part, and energy and power signals. Okay, deterministic and random signal. Just you have to know the definition. Okay, deterministic and random. Just know the definition for this. And continuous time, discrete time is basic classification of signals. Okay, everywhere you will be using continuous time or discrete time. And the operations we have seen now: shifting, scaling, time reversal, correct? And we have amplitude scaling. Last priority. According to the law of precedence, you go on. First shifting, then scaling, then time reversal, then amplitude scaling. Then we have seen elementary signals. So we have seen unit step, U of t or U of n, unit ramp, R of t or R of n. Okay, and we have seen impulse signal delta t or delta of n. Okay, and based on these, we have solved all the problems. So anything if it's remaining, we'll solve it in tomorrow's class. You want me to repeat any topic? Are the topics clear to you, unit 1?
Yes, ma'am.
So if you want me to repeat any topic, you can tell me today only. Okay, so that I will do that tomorrow's class. Clear, everyone?
Yes, ma'am.
What about others?
Yes, ma'am.
Yes, ma'am.
It's clear? Okay, guys, then we can wind up this class. If you want me, if you remember later also, if you want me to repeat any topic, you can message me. Okay, I'll do that problems in tomorrow's class. Okay, guys, then we can wind up this class. Thank you.
Thank you,
Thank
ma'am.
you, ma'am.